Okay, so here's a walkthrough of the test that you recently sat. Okay, so this first page details the names, the formula, and a structural diagram of these three compounds here. And from this, we can identify which of these symbols represents which elements. So if we have a look at this one and this one, we can see two, they both contain the black circle, which must be the hydrogen. This diagram gives us the two white circles, which must be the oxygen, and that leaves us with the hatched circle, which has got to be carbon, and the grey circle, which has got to be nitrogen. Okay, so this one is hydrogen, this one is nitrogen, and the next one is oxygen, and this one is carbon. And generally speaking, everybody did very well on that. So there were 2 marks for that. Basically a mark for 2 of the elements present. We then move on to the next question. Using the same symbols as in the previous question, you were asked to draw carbon dioxide, CO2. I'll actually put that on screen so you can see it. Okay, so that's CO2. So we use the symbol for carbon that we saw in the previous page, and there's 1 carbon, so there we are, and then the O's would go either side. And it's important that we make sure they're touching, and for these sorts of diagrams, you don't need to draw any lines in to represent the bonds. The fact that they're touching each other is sufficient. Then you're asked to draw nitrous oxide, or dinitrogen oxide. So there are 2 nitrogens in this one and 1 oxygen. So we would draw the central oxygen, and then we would draw 2 nitrogens, and trying to make that grey rather than black is a little difficult, but there we go. Okay. And then finally, ethane. Okay, quite a difficult one this, and it was very encouraging to see most people getting this correct. The 2 carbons here sit side by side. We have to cross-hatch those, and then the 6 hydrogens would be arranged 3 on each of the carbons around the outside. Okay, and it is important that you get this order correct. So for example, if you were to draw this for the first one, you wouldn't get the mark, and there are various combinations of the other molecules that also wouldn't get the mark. Okay, so it's important that you get them in the right order. For the next question, how do the formula and diagrams in the table show that oxygen is an element? So if we briefly bring this back in, we can see that oxygen is an element because it contains 2 of 1 type of atom, or 1 element. Okay, so oxygen is an element because it is made from only 1 type of atom. Okay, so it's the key word there is type of atom. If you said only 1 atom, that would be incorrect, because that would imply that it was 1 single atom on its own, whereas oxygen is made up of billions upon billions of oxygen atoms. Okay, methane is a compound. There's 2 key features to this. We need to say 2 different types of atom, and you don't need to name them, but you could. Which they are, of course, carbon and hydrogen. And then the other key point is they are chemically bonded together, or simply bonded together is the other feature we're looking at there. Oh, 2 marks, 2 distinct points there. Okay. This next question was generally very well answered, but just to go through it, the chemical formula of ammonium carbonate. So remember that anything inside a pair of brackets is modified by the number that happens after the brackets. In this instance, it's a 2. Okay, so the first question says state how many nitrogen atoms are present in the formula NH4 twice CO3. So there's 1 nitrogen there, however, there's a 2 after the brackets, and therefore it's 2. There are 2 nitrogen atoms. How many different elements are present in the formula? So here we're simply looking for different chemical symbols. So there's a capital N, a capital H, a capital C, and a capital O, all of which are the symbols for different elements. So that would mean there are 4 different elements. And then this final part of the question asks for the total number of atoms present. So within the brackets, we've got 1 nitrogen and 4 hydrogen atoms, which is a total of 5. No, it's not. Yes, sorry. It's a total of 5. There's 2 of them, so that's a total of 10 altogether for the NH4 part, plus the carbon, and plus 3 oxygens. So that's 10 plus 4 is 14. So there are 14 atoms altogether. Okay, moving on. So this question was a simple version of an empirical formula question. It says aluminium reacts with chlorine to form aluminium chloride. Aluminium chloride forms a molecule with a chemical formula Al2Cl6. Give the simplest formula or empirical formula of the molecule of aluminium chloride. So remember that the simplest or empirical formula is the lowest ratio possible of elements in a formula. And so in this instance, it would be AlCl3. If we double that, we get that. Okay. The next question, the table shows some information about the composition of some chemical compounds. The information for the compound potassium nitrate has been completed for you. Complete the table. Okay, so this question does address a couple of different skills. I'm just going to dig out the table from the back that we will need shortly. Okay, so the first row here, what you'd be expected to do is to identify these ions from the table. Okay, so the table was at the back of your book, of your test rather. So Li is lithium and O2 minus is oxide. Okay, so you can use that information to name the compound. So lithium oxide. And then the second thing you need to do, the second skill you have to be able to show, is that you can work out the formula. So we can see that a lithium ion is a single positive charge, an oxide ion is a double negative charge. So consequently, we would need 2 of these to balance one of those to ensure that the overall formula is electrically neutral. And we would write that as Li2O. Okay, so that would be the formula of lithium oxide. For this next one, possibly more difficult, iron 3 carbonate. Okay, so iron, as we can see from here, does come in 2 different forms. There's iron 2 with a 2 plus charge and iron 3 with a 3 plus charge. So this is the iron 3 plus. Okay, so you would need to write down Fe 3 plus, and it's important that the charge is a superscript, goes at the top. Okay, now having found that formula, we now need to work out how many of these will balance or cancel out how many of these. So this is 3 plus and this is 2 minus. So if you cross multiply, so therefore we end up with 2 of these and 3 of these, that would give us a total positive charge of 6 plus and a total negative charge of 6 minus, which cancels each other out. And then we would rewrite that as a formula as Fe2, and then we would need some brackets here and say CO3 3 times. Okay, so that's quite a complex one there, and those people got that correct. Well done to them. Nickel fluoride. So for this one, we need to identify the symbols for the nickel and the fluoride ion. So nickel, okay, is on here somewhere. There he is. Ni2 plus. Okay, so that's Ni2 plus. And the fluoride, if we have a look on here, fluoride is here, which is F minus, or F1 minus if you want to add in the number. It's the same. Okay, and from that we've already got the formula. Okay, and then finally, this one caused some people some problems, I think. We need to identify the name of the compound. So if you look, we've got some clues here. We've got NH4. Okay, we look at the table, we'll find that NH4 is an unusual positive ion in as much as it's got no metal in it, but it's called ammonium. And then we need to identify what goes here. Well, if we have a look at the formula over here, we'll notice that we've got SO4. And if we have a look at the table over there, we'll find that SO4 is sulfate. Okay, and then so we need to write in SO4 2 minus, taking care to put the 4 meaning 4 oxygens at the bottom as a subscript and the 2 minus at the top as a superscript for the charge. And that means that this is ammonium sulfate. Okay, so we're moving on now to the next question. And this question tells us some things that we need to remember or use later on in the question. So potassium nitrate reacts with aluminium hydroxide to produce aluminium nitrate and potassium hydroxide. Complete the symbol equation for the reaction by giving the formula of aluminium nitrate and balancing the overall reaction equation rather. Now, given the formula for aluminium nitrate, that's to go in this cap here, we're doing exactly the same as we've done in the previous question. So we can refer back to our table and we find aluminium, which is right at the top there. So aluminium is Al3 plus and nitrate is NO3 minus. So from this we can work out that for every aluminium we will need 3 nitrates because aluminium is 3 plus and nitrate is minus or 1 minus. So we'll need 3 of these to balance or cancel out one of those. And because this is a compound ion, we will need to use brackets to write that formula down. So the formula is Al, we just need one of those. Then we open a bracket to put the NO3 into. And as we've already discussed, because aluminium ion is 3 plus and the nitrate is simply minus, we'll need 3 of those. Okay, so that was for the first mark. And then we need to now balance this equation. Okay, so if we use the boxes method, if we go for K, N, O, 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 so that's KNO3 represented as a box. So that's one molecule. AlOH3, so that's Al, and then we've got 3 O's and 3 H's. If we expand the brackets, and then this one's a bit of a monster. We've got an aluminium, and then we've got 3 nitrogens and 9 oxygens. Put a box around that. And then KOH is 1K and 1O and 1H. Okay, quite straightforward, that one. So if we have a look, at the moment, we've got 3 oxygens here, plus the 3 there, that's 6. But here we've got 9, 10. Okay, so we've got 6 on this side, and we've got 10 on this side. So we need to consider how can we adjust that, how can we change that so that we end up with the right number. So if we add another 2 KNO3s, okay, and if we add another 2 KOHs to match the Ks primarily, we will find actually that does balance our equation. We've got 3 potassiums here, 3 potassiums here, we've got 3 nitrogens here, and then we've got the 3 nitrogens here. We've got 9, 10, 11, 12 oxygens here. We've got the 9 there, plus the 3 here, which is 12 oxygens there. And then with the aluminiums, we've got 1 and 1. Okay, so overall, this does balance the equation. What you do need to do is to then put these numbers in the box, our friends, the stoichiometric coefficients. So we put a 3 there, and we put a 3 there. Okay, so that's the other markers. So quite a lot of work really for 1 mark. Well, there we go. So we've got a 3, 3, and the formula for aluminium nitrate. Okay, so moving on to the next question. Give the name of the method used to separate the following: sand from a salt solution. And the majority of people got this correct with filtration. If we want the salt from a salt solution, then we can use the evaporation method. And then slightly more difficult, if we want the water from a salt solution, we need to use distillation, because we need to evaporate off the water, and then we need to condense it back into liquid water. So we've got the water. That was distillation. Okay, now moving on to the next part, we've got another balancing equation. So potassium chloride is one of the salts present in seawater. When potassium chlorate, that's KClO3, is heated, it forms potassium chloride and oxygen. Balance a simple equation that represents the reaction taking place. So if again we use the box method, so KClO is the box. So there's 2 of these. Okay, so we're given that in the question, so we can assume that that's going to be all we'll need. And then KCl, we don't know how many of those there are, but the very fact there's a box there tells us that we are going to have to change that. And O2 is here again because of the box there. The WJC don't just put boxes there for no reason. There will be something going in there. So if we look over here, and we know that this is complete because it's already, the coefficient is already there. We've got 2 potassiums and 2 chlorines, which does sort of suggest that we're going to end up with another potassium and chlorine here. That way those now balance. We've got 6 oxygens altogether here. We've currently only got 2, so we would need another 2 of these, so that we end up with a total of 6 oxygens. And that means that we need to put a 2 in this box and a 3 in this box. Okay, so moving on to this next question. A student carried out an investigation to find out whether pigments E, F, and G are present in a blue felt pen. The student used a solvent called acetone instead of water. The results are shown below. So give the name of the method used. That was chromatography. Chromo comes from the word for colour, because very often these different blobs are different colours. Okay, but there are various uses of chromatography. Explain why pigments travel different distances on the chromatogram. Now, this wasn't answered as well as it might have been. Okay, so the reason is that some pigments are more soluble. The key word there is soluble in the solvent, which in this case is acetone. And therefore move faster or further up the paper. So the key fact there is the solubility of the pigment means that it does move faster up the paper. So this pigment here was the most soluble one of any of the ones in the experiment. Okay, so it moved further up the paper. And then state what the results tell us about the blue ink. Okay, so these are 3 known pigments, and this is a blue pen. And the idea of this particular experiment would be to discover which pigments were present in the blue pen. And so we can see, if we look across the chromatogram, the blue ink does contain pigment E, but it also contains this pigment here, which doesn't match any of the others. So basically, the blue ink contains pigment E and another mystery pigment. Okay, so or just another pigment basically. So that's what we can ascertain from that chromatogram. Okay, now then, having established that, we now need to calculate the RF value. Now this question is typical of an RF value question, as much as the equation is actually given to you, how to do it. So as long as you read the question carefully, hopefully we can get the question right. So if we look back at our original picture, okay, then we try and rule a horizontal line across here. So we can see that is each of these lines is worth 0.2. So that's just a smidge short of 0.4, isn't it? So 0.4, that's 4.4. And the pigment, the acetone, sorry, the solvent has travelled 5.0. So if we go back to our question, then we've got 4.4 over 5.0. Okay, and if we double check that with the calculator. Okay, so 4.4 divided by 5 gives us 0.88. I was reasonably lenient with this question due to the fact that this value here, there was a little bit of variety in it, but as long as you got the method correct, then I gave you the benefit of the doubt. Okay. Right, this next question, slight change in tack. It's dealing with the acetone, which is the solvent, but it's not really about the acetone. It's about percentage by mass of carbon in acetone. Okay. So what we need to consider is, first of all, the MR of the acetone overall. So MrC3 H6O. Okay, so we've got 3 times 12, okay, which is 36. We've got 6 times 1, which is 6. And then we've got the 1 times 16, okay, which is 16, obviously. And then if you add all those up together, then we get 58. So that's the MR. And then the question asks the calculate the percentage by mass of carbon in the acetone. So if we look here, the percentage by mass of the carbon is the 36, because there's 3 atoms of carbon. So 36 divided by 58 times 100 is 62.1, or simply 62. Okay, so that's the percentage by mass. Many people forgot to multiply by 3. Okay, they used 12 over 58 instead of 36 over 58. Okay, so just take care with that aspect of it. And then moving to the last page now, where we had some of the more difficult questions. So in order to, this is the question where I've taken it out for one of your values, one of your percentages, because as I said in the lesson, it's a little unfair to include this, as we'd only just done them all the previous lesson. Some people were absent due to the Welsh Baccalaureate. Okay, but anyway, to do this question, to use the method that I showed you, you could try and remember the triangle, okay, which has mass at the top, it has moles, and it has MR. Okay, we need to identify which of these different values are in the question. So in a class experiment, a student was given a solution containing 0.571 grams of sodium hydrogen carbonate. So the grams tells us that's a mass. Okay, so if we put that down here, so we've got the 0.571, and then it goes on to say the relative formula mass of sodium hydrogen carbonate is 84. So obviously MR is our MR, and the question asks you to calculate the number of moles. Now a lot of people got this far. Sorry, I need to replace that with the 84. That's the 84, isn't it? So basically from the triangle we want to know moles. So moles equals 0.571 divided by 84. And some people got this far and then put the wrong calculation into their calculators. So let's put that in exactly as it appears. Let's get rid of our previous entry. So 0.571 divided by 84 is 0.0067. Okay, and it does ask you to quote the answer to 3 decimal places. Basically it's 0.007. And I suspect that some people were put off by that answer. They probably saw it on their calculators and assumed it was incorrect. But if you consider that you've got a small number divided by a big number, that is going to give you an even smaller number. Okay, so 0.007 is the correct answer. And then the final question, okay, you could do this one of 2 ways, okay. So the straightforward way of doing it is to use the masses given to you in the question. Okay, actually no, you can't do it one of 2 ways. There's one way of doing it. Okay, so we're calculating the relative formula mass of copper chloride. Okay, so the MR of copper chloride. So the copper there weighs 63.5, and then the chloride, I think a lot of people forgot the 2. Okay, so it's 2 times 35.5, okay, which is 71, and so 63 plus 71, so 63.5 plus 71, so 63.5 plus 71, 134.5, 134.5. Okay, having calculated that, we can then go on to use that value in the final question. Okay, it says calculate the percentage mass of chlorine in copper 2 chloride. So we've already calculated here the mass of the chlorine in copper chloride, and we know the MR of copper chloride. So 71 divided by 134.5 times 100. So we'll do that live on the calculator. Okay, so 71, will it cancel. 71 divided by 134.5. If we times that by 100 just to is 52.7% or 53%. 53%. Okay, so hopefully I can help you understanding where you went wrong.